Let's look at how the router used the routing table to route incoming packets. Okay, the routing table is a hierarchical structure such that it can be used to speed up the lookup process. Okay, the hierarchy will include ultimate route, level 1 route, level 1 parents route, and level 2 child route. Okay, first, the ultimate route. The ultimate route is a routing table entry that contains a next hop IP address or an exit interface. So looking at this routing table, all those that's highlighted are ultimate route because they either have an exit interface or they have a next hop. Okay, exit interface, next hop. Okay, so directly connected network, dynamic learn, and local route are all ultimate routes. Okay, let's look at those that's not ultimate route. Okay, if you notice, the two that's highlighted in white are not ultimate route because they do not have any exit interface and they do not have a next hop IP. So because they do not have this, they are not ultimate route. Okay, next, level 1 route. Okay, level 1 route can be a network route. Okay, network route is a route that have a subnet mask that's equal to the classful subnet mask. Okay, so in this example, okay, we have a /24. Okay, 192.168, if you remember, anything that starts with 192 is a class C network. Okay, so this is a class C network. So class C network, the default subnet mask is /24 or 255.255.255.0. Okay, so in this case, this is a network route because the subnet mask matches the class. So this is a class C, you have a /24. Okay, a supernet route is a network address where the mask is less than the classful subnet mask. So this is a summary route. Okay, for example here, 192.168, okay, by right it should be a class C, but the subnet mask is /16, which is less than the classful. So the classful is actually /24, but the actual subnet mask that we see in the routing table is /16. So in this case, it's a supernet. So this can be also a level 1 route. Okay, the last type of level 1 route is a default route. Okay, a default route is a static route with the quad 0. Okay, so we know that this will be our gateway of last resort. So all these three could be a level 1 route. Okay, and if this level 1 route has an exit interface or a next hop IP, then this will be called a level 1 ultimate route. Okay, then this can be called a level 1 ultimate route. So if you look at the routing table for R1, okay, we have two level 1 ultimate route. This is a level 1 ultimate route, which is your default route, and this is another level 1 ultimate route. Okay, so this is actually a supernet, a /16, and you have an exit interface and a next hop. Okay, how about this? Okay, this is also a level 1 route. Okay, 172.16.0.0/16. This is a network route. Okay, but this doesn't have a exit interface or next hop. So this is what we call a level 1 parent route, which we will look at in the next slide. A level 1 parent route is a route that has been subnetted. When you do a show IP route, the routing table will show the word variably subnetted. Okay, so in this case, we have two level 1 parent route. Okay, one is going to 172.16.0.0/16, and the second one is 209.165.200.0/24. So these two are your level 1 parent route. In addition to the two level 1 ultimate route, your default route, and a route going to 192.168.0.0/16. So in total, we have 4 level 1 route here in our routing table. 2 are ultimate route, 2 are level 1 parent route. Finally, we have our level 2 child route. A level 2 child route is a route that is a subnet of the classful network address. Okay, a level 2 child route obviously appear under a level 1 parent route. So remember earlier on, we have two level 1 parent route, okay, the 172.16 and the 209.165.200. So under the 172.16, these are the child route from here, or the 172.16. Under 209.165.200, these are the child route. Okay, so this child route belongs to the first parent, this child belongs to the second parent. Also remember, all level 2 child route are also ultimate route. That means they definitely have a exit interface or a next hop IP. Okay, so how does the router use the level 1 route and level 2 route for its lookup process? Okay, first, he will try to find a best match. Okay, later we'll talk about what is the best match. Okay, if the best match is a level 1 ultimate route, okay, that means when a router receives a packet, okay, he will look at the destination IP address. He will try to match the destination IP address to one of the route in level 1. Okay, remember the level 1 route will contain all the network address. So he will try to match this destination IP address with a level 1 network address. If the best match is a level 1 ultimate route, then he can use to forward the packet. Because remember, ultimate route have an exit interface or a next hop IP. Okay, but if the best match is not a level 1 ultimate route, instead it's a level 1 parent route, this means that now they need to look at the child. So they'll go in and look at the child. If there's a match with a level 2 child route, then it can be used to forward the packet. Because remember, all the level 2 child route are all ultimate route. So if they can find a match in the level 2, then they will use. But if they go into the level 2 but can't find the match, okay, if they can't find a match, then they will continue back to level 1, okay, to search for a supernet or default route. Okay, supernet or default route are not the best match, but they will still match. Okay, but unfortunately they are not best match, but they will still match. If there's a match, then they will use the route. But if they search, there's no level 1 super route that's matched and there's no default route, then the packet will be dropped. Okay, what does it mean by a best match? Okay, a best match is a route that has the most number of far left matching bits, okay, that matches with the destination IP address of the incoming packet. Okay, for example, okay, the router receives a packet. Okay, so this router receives a packet and the destination IP address of the packet is 172.16.0.10. Okay, this is the binary equivalent. Okay, and on the routing table, okay, we have 3 routes. Okay, we have 3 routes. Okay, one is 172.16.0.0/16. We have 172.16.0.0/18 and 172.16.0.0/26. So which of the route will the router use? Okay, if you notice, okay, actually these 3 routes all matches with the IP, the destination IP address. So I can effectively use any of the 3 routes, but the router will choose the route 3. The router will choose route 3 because route 3 say match 26 bit and the IP address matches the 26 bits. So these have most number of batch. Although route 2 also match, it matches 18 bit, but because this match more, you have more number of matching. So route 2 will not be used. Similarly, not for route 1, they will use route 3 instead. Okay, why is this important? Okay, if you look at the default route or the gateway of last resort, okay, default route normally is 0.0.0.0/0. This will be my default route. Okay, notice default route say I do not need to match any bit. Okay, so default route will match all the packets. But why we call this the gateway of last resort? Because although this default route matches all the packet, okay, basically it doesn't match any bit, so it will match all the packet. Okay, and so default route matches all the packet, but we want it to use as a gateway of last resort. So we want the router to try to match as many bits as possible in the earlier route. Okay, in any of the route. If they try and still cannot match, then I will use the default route, which will match all the bits as the last resort. Okay, so that's why the route with the greatest number of bits will always try to use first. They'll try to use until cannot match. Then when you have a default route which matches 0 bit, it will then be used as the last resort. Okay, next we will look at the IPv6 routing table. Okay, this IPv6 routing table is much simpler than IPv4 because all IPv6 routes are level 1 ultimate route. There's no level 1 parent route or level 2 child route. Okay, let's look at the directly connected routes for IPv6 routing table. So to show the routing table, we run the show IPv6 route command. And the directly connected network, similarly, they have a C and an L. C is for the network, the directly connected network. L is for the IP address of that interface that's connected to the directly connected networks. So it's similar to IPv4. So we also have the administrative distance and the metrics for directly connected networks. So for IPv6 and IPv4, they are the same. Okay, so for directly connected network is the administrative distance is 0, and obviously metrics is also 0 because it's directly connected. And also we have the outgoing interface. Okay, the interface that is connected to this directly connected network. Okay, for the remote IPv6 entries, we also have the different entries like O for OSPF, D for ERGRP, R for RIP, and S for static route. So these are the different sources that can generate these remote network entries in a IPv6 routing table, same as IPv4. They also have a next hop. Okay, so this will be the IPv6 address of the neighbor router that this packet should go if the destination IP address of the packet matches this network. Okay, you also will have the outgoing interface. So again, the lookup process, they will try to find the longest match, the one that matches the most number of bits. And because they are all level 1, so we'll just examine the level 1 for the best match for the ultimate route. Okay, so in summary, we have looked at the different function, okay, the purpose of using dynamic routing protocol. We'll look at how do we configure RIP version 2, and we'll look at the routing table, okay, to find out where's the route source, what is the administrative distance as a metric of a given route, and how does a router look up the routing table in an IPv4 routing table and in an IPv6 routing table.